Hello everyone. So this is my first video ever for Gitlab. I'm not sure if the quality of the video and audio will be good enough. So if you have feedback on the audio or the video, let me know. I'm happy to hear it. My name is Fred Gier and I'm going to work on AI Assist. So the last couple of weeks I've been working on onboarding, going through all of the tasks, getting to know Gitlab, the way we work, and also hear about ideas on AI Assist and figure out what we're going to actually build. So most of this week I've been spending time on drafting the vision for AI Assist, which I want to elaborate upon during this video call. And please give me feedback on this because it's a very broad subject and we can go different ways, different approaches, and I want to iterate as much as possible. So let me share my screen and I'll guide you through what I've written down this week. So the first thing that I wanted to do is explore the concept of AI and also, but mostly determine what is AI and what does it mean for AI Assist and for Gitlab. Because the term AI is AI standing for artificial intelligence is being widely used everywhere and anywhere right now. According to the Oxford Dictionary, artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. There are, of course, many more examples of what AI is. One of the things that I notice AI to be right now for a lot of companies, it's a great buzzword. If you have a product, that's great. But if you have an AI product, that's amazing. People want that. It has a higher perceived value. One of the subdomains that I've been working on for the last couple of years is machine learning. I think machine learning and data science have been going through the same hype effect as AI. What used to be called data analytics became data science. It then became machine learning, and then machine learning became AI. And this changing of the terminology is a bit confusing because machine learning is part of AI and data science is not per se machine learning or AI. It can also be advanced analytics, but also deep learning, neural networks, all subsets of AI. In my opinion, the most important aspect of AI is the self-learning aspect and the continuous learning. So if we strive for a machine learning model with a feedback loop, we can do something that's called continuous learning. So our model will continuously learn from the feedback that is provided. So let's say our model predicts a classification of group A, and a user gives feedback that it shouldn't be group A, it should be group B. We can incorporate that feedback into our model to make it learn from the mistakes that it has made, because everything changes constantly. Data might change, behavior might change. You need to measure this drift and continuously adjust for it. So the other thing is that AI is very broad and we want to make it a bit more specific. The difference between an AI feature and a normal feature is that you are using, for example, a machine learning model, and that model needs evaluation. So instead of just doing your, let's say, A/B testing on your feature, you also need to do A/B testing on your model, because how else would you know if your model is actually performing well? So I think a lot of features in the future will incorporating aspects of machine learning or AI, and it will become more and more common to use these features. If we think about AI features and how it can benefit GitLab, I think of a couple of features that we can incorporate AI to improve the experience, such as pipeline optimization. We could analyze pipelines, and based on a lot of different pipelines, we could already start suggesting a more optimal pipeline, for example, optimized for speed. The same could be done for builds. For example, Docker files are usually not properly optimized for caching, meaning your build will take way longer compared to when you have a proper caching strategy. And there are plenty more ideas that we can think of. I've written down a few. The one that I'm going to focus on is code optimization. And in the beginning, specifically focused on security practices. Why should we do that? Well, there are a couple of reasons. The first one is code optimization is a very broad and explorative subject. It can go in different directions. So it's very explorative, and therefore it's a good fit for incubation engineering compared to, for example, build optimization, which is much more narrow than code optimization. The second point is that it extends upon a subject that users are already exposed to, and GitLab has a lot of features for it. Like the existing tools, such as container scanning, dependency scanning, etc., secret detection, those are all very correlated to code optimization, especially secret detection. So it's not that we have to bias against introducing something new, because we already are familiar with these tools and our users as well. So we're just extending upon that knowledge already. Third point is security is becoming increasingly important. Every week you will hear of some breach or some incident or some vulnerability. So it's important that we help our users write secure code. The fourth point is that it allows integration with existing tools and therefore boosting their efficiency. We already have a lot of tools within GitLab that are analyzing code, for example, or could be used. Maybe users are not using it. So by optimizing their code, we could connect to these tools and create more exposure for them. I haven't experienced any of these tools yet in GitLab. That's something that I'm going to do next week. So this point four, I might have to come back on it based on the learnings that I will do next week. So our mission is basically our big, audacious, hairy goal, and that is to create an assistant that will help users write secure code and educate them why this is secure code and why what they were doing before is insecure. To start building anything, there are a few hypotheses / underlying assumptions that we need to validate as soon as possible. This is also in line with the iteration flow and also the lean startup methodology. The first assumption is that users want GitLab to proactively help them detect optimizations to their project. I think this is key because we can suggest anything, but if users are not willing to accept our help, they will never use it. The second point is that we are capable of providing meaningful suggestions. This assumption is a bit more vague. The reasoning behind it is that there are currently already a lot of linters, code analyzing tools, security tools, but they create a lot of, let's say, noise. Because if you ever looked at a container registry, you will see many warnings about vulnerabilities, either severe or insignificant. And a lot of those are ignored, either by policies set within the company or by knowledge that it doesn't really, or it doesn't pose a problem for that specific situation. So we need to figure out how we can provide meaningful suggestions. Like we need to learn what is and isn't a problem or a good suggestion for a user. The third assumption is that the users are willing to accept and or provide feedback on our suggestions. So this point is crucial for our self-learning capabilities. So if we provide a suggestion to a user, ideally we would want them to accept it or provide feedback on it, so we know if our suggestion was good or bad. So breaking it all down into our strategy, I think we should start simple and aim towards validating the assumptions. So for the first step, we will use off-the-shelf products, such as security linters that are currently there, and we start just with one language, just to get feedback on the approach. Is this something that users are actually looking for? We won't create any new machine learning models, because that will take way too much time and effort, and it does not help validating our assumptions. So the second point is to seamlessly integrate the output of step one into the UI. Currently, if you have any kind of linter, which will run in your CI/CD, and there's a problem, your step will fail, and you have to go to the logs. So for example, this one is correct, but all of the output usually is right somewhere here. For example, this one, all entries have a GitLab username. But if it didn't, it would be a similar output, but in this case, a file, or it would have a file and line number. If we start to integrate the output into the actual repository, we could see our output of linters only the warnings and errors in our repository. And it will become probably much easier to figure out what if there's an issue. And we could start linking it also to external information, like why this is an issue. Based on the first two steps, we need to figure out what the shortcomings are, because step one in any machine learning project is to determine what is actually the problem. So if from our learnings, we figure out that there's a gap, or certain features or certain aspects are not being detected properly, or then we have our problem. We need to start detecting those, or we need to start figuring out what is the noise and how can we filter that out. For step 4, this probably can tie in with point 3. Not sure which will be the correct order. But as I said, the first two will create a lot of irrelevant warnings due to the specific situation of a user. So we could look into training a machine learning model to determine the relevancy of a specific problem to the user. This can be fed by just a rule-based system based on what the company has already set out for what they care and what their specific situation is. For example, the warnings might be dependent on where you are running your code. Is it on-prem? Is it in Azure or Amazon? Next step would be to determine the most effective suggestions, like what is actually benefiting our users in improving their code. Because probably those suggestions are the ones that are most meaningful to a lot of people, and it would make sense to start exploring if we can find more of those suggestions. So based on all of these learnings and linters and tools that we're going to explore, we perhaps could build our own linter, mostly based on the learnings that we get from experimenting with these linters and receiving the feedback from the users. That linter will still just run in the CI/CD part, and in the next point, we could look into integrating the GitLab linter into IDEs for real-time suggestions. That could also become very relevant for pipelines, for example. Sometimes you write a pipeline and the linter can already detect that it won't work. And the current GitLab CI linter already would detect that it is a problem in the but you wouldn't know that right away. You would have to copy your pipeline, put it in the linter on gitlab.com, and then copy it back over. And the last point comes back to the big audacious hairy goal, or our mission. That is that whatever we have learned and created in the first 7 steps, we will evolve into GitLab Assist. So what could GitLab Assist be? For years, developers have been exposed to code completion tools, such as IntelliSense, autocomplete. Basically, every IDE has it right now. And started to incorporate AI into code completion tools. A few examples, Step9, Guide, but of course also Copilot from GitHub. These products are very illustrative of what people would consider to be an AI. It's almost magic, right? You type something and this whole text appears, your code. You could accept it. Maybe it's useful, maybe it isn't. But there are a few concerns. Most of the applications currently out there are using GPT, so basically the same model and making tweaks on that. It takes tremendous amounts of data and compute to train such a model. This is where it gets a bit more tricky. There are 2 issues with the input data. First off, there's a limited set of data and everyone has access to it. So it's a plain level playing field. The other concern is that public repositories are not perfect. Some of them are not optimized for security nor for coding best practices. They're just a place also for a lot of people to just store code. So if you're going to use all of the data available, you would probably not have the right quality level. So you would need to assess the quality of a repository or improve the quality of a repository before using it as input data. The last point is that it's one thing to suggest code, but it's another thing to educate users why it is good code. All in all, I think the chances of code completion becoming a commodity are fair, even with the help of AI. It might be worthwhile to take it a level higher, for example, full boilerplate templates. Let's say you just type that you want to make a Python API for a user database in MySQL, and that would give you back a full boilerplate template or repository, including security best practices. This would still be suggestive and not educative, but maybe we can incorporate it as well, because that would also eliminate the time needed to actually write code. Coming back to our mission and where GitLab Assist might grow to, it all depends on the learnings as we go along, but it might be that GitLab Assist will become very similar to the core functionality of a code completion product, but it will be different because it will educate users why certain code is safer or more effective, but let's focus on security. It can adhere to company coding guidelines, be aware of licensing. So that is basically what I had written down based on chats that I had with different people, but also just thinking about it and brainstorming over this idea and writing something down. I think the aim was to start small and start iterating and collecting feedback. So if you watch this, please provide feedback. I'm happy to discuss. You can comment on the merge request. I still need to create a project, issues, that kind of stuff. If you have any suggestions on what I should do, where I can start, where I can, any tips on creating these issues, let me know. I'm available on Slack. Thank you very much. Bye-bye.